diagram for a pure substance, right? So first of all, what is phase? What is mean by phase, right? Phase is a state of any substance, right? As we know, any substance, it may exist in a solid state, liquid state, or in a gaseous state, right? So it is depend on the temperature and pressure, right? So it will in the form of ice. Substance, pure substance, it's a water, right? So here pressure temperature diagram here, right? In a axis is there, this is the pressure, and here it is the temperature, right? So initially ice or at a very low temperature, or we can say water at a very low temperature and pressure, right? So here this is a very low temperature and pressure, right? So we are fixing this pressure, right? This is at a constant pressure. We are heating the ice. What will happen when we heat it, increase temperature at this point, right? This point it will convert into vapor here. So this state, it's a solid state, and here it will convert into vapor, right? And again we are fixing the higher pressure, means greater than this initial pressure, then we will reach here this point. After this point it will completely convert into vapor. Here this is a vapor. Then further increase pressure, we reach this point, right? At this point we see this solid exists in a three phases here. So it will convert, all three phases are exist at this point, means here liquid also there, solid and gas also there, right? So here this is solid, right, and here liquid also get start here at this point, and further we increase temperature, so it's a completely vapor, right? Then further we increasing the pressure, for example 1 atmosphere pressure, P equals to 1 atmosphere pressure, right? So here at a 0 degree, this temperature is 0 degree centigrade. At a 0 degree centigrade it will start melting, right? And further we heat it, so we reach at this point. At this point it will start convert into the vapor, right? Further heating, it will completely convert into vapor, right? So further we increase pressure, so we will get this point, right? This is for melting and this is for vaporization. So similarly, so when we connect these point, so we will get this curve, right? This type of curve. This curve is called phase diagram, right? So phase diagram, a graphical representation of various phases of substance or mixture of substances, right? So this is the phase diagram for water, right? So here interesting thing is when we are increasing the pressure, right? So what will happen? The melting point, this is the melting curve, this is the vaporization curve, right? And this is called sublimation. sublimation curve. Sublimation curve means when any substance directly solid to vapor, it will convert directly solid to vapor, not in a liquid form, right, in a liquid state, right. So such curve is called sublimation, right. So here it's a pure solid, means here it's a ice form, and here it is water, we can say in a liquid, right. This is liquid, and here this is the vapor, right. This area is vapor. When so this point where all three phases are coexist, this is called triple point. So it is represented by T. It's a triple point, right. And in this point all three phases are coexist. When we connect all these points, right, so we will get this curve, right. So here this T, this is the triple point, right. Triple point where all three phases are coexist. Here we can see here solid, here this side this is solid, this is liquid, right, means liquid means this is water, and this side is vapor, means steam, right. So this curve is called sublimation curve. Sublimation curve where any solid convert directly into the vapor, right. So here this curve is called melting curve, because here solid is converted into liquid, right. But here this is the special case, right. In water, here this curve have a negative slope, right. Reason behind it, because we know the density of ice is less than the density of water, right. So here we will get the negative slope, right. This triple point pressure is 0.611 kilopascal and temperature is 0.01 degree centigrade, right. So this point it's called a triple point where all three phases are coexist, right. When we reach at a pressure of 22.06 megapascal, so at this pressure, this is called critical pressure, right. Critical pressure, temperature corresponding it 374 degree centigrade, or pressure is 22.06 megapascal. Above this super critical water, right, means no distinction between the liquid or vapor, means above this we cannot recognize it's a liquid or it's a vapor. Here key points is there are, this is the fusion curve, or we can say this is the melting curve, right. Solid liquid boundary, right, this is the solid liquid boundary. Negative slope, right, here this is the negative slope. Unique property of water, that is ice is less dense than the liquid, right. Increasing pressure, the melting temperature decreases, right. Here we reach, for example, here we are here, this is the melting temperature corresponding here, this is the melting temperature. When increase the pressure at, for example, this point, so here what is the melting temperature corresponding when we draw the perpendicular line, so we will here, right. So it means increasing pressure, so melting point of solid, here it means ice, right. it's decreasing. Critical point is a special point on a phase diagram where the liquid and vapor phases become identical and cannot be distinguished from each other, right? At this point, critical temperature, above this temperature liquid cannot be exist no matter how much the pressure is, right? This is very interesting point, right? So critical pressure is the minimum pressure required to liquefy a gas at a critical temperature, right? Please like my channel and subscribe my channel.